The next winner you've already seen. We had 3 challenges, so the next winner will find something. They were short of having an inspiration for their name, so they'll find something was their name.
Thank you. Hello. It's an impressive crowd. So the button is okay. So yes, as you said, we were a bit short of inspiration for the name of our team, but we were glad that we actually found something in this hackathon. With my colleague Ruben, that is here, and Peter, we are data enthusiasts, but we are from Melexis, a semiconductor company with headquarters in Belgium. And we deliver automotive microelectronics. So the chemical and the process on which we worked in this hackathon was a bit new for us. But we had the pleasure to work with Adrien and Andrea from P&G, who helped us to get some insight in the data and understand the challenges that you face. Well, you're all a specialist of data science, but one thing, when you get such a data, it's a bit intimidating to start with, and it's always a trade-off that you have to make between keeping most of the information in the data set, but also trying to make it a little bit smaller, to make the data size manageable so you can really make fast iteration in your models, etc. So in the end, you have to make choices, and I like to share them a bit with you. Okay, it's based on experience, intuition, and let's face it, also luck. We decided to keep all the continuous variable so we have information from all the process steps and from all the lines in the manufacturing plant. We discarded the discrete variables. But we made a drastic resampling of the data. We kept from the 5-second sampling interval, we went to 1 hour. So this helped us to make the analysis faster. And we also built our own aggregation of the total power consumption of the plant. In the end, we ended up with a predictive model, so we found out that the total power consumption of the plant can be predicted with only 14 variables out of the 1200, with a pretty good correlation. So you see the results here of 6-month data of the electricity consumption, and the red line is actually our model. Of course, this model was good on the 6-month data, but we were curious to see if we maintained the same accuracy for the next 6 months. And it works pretty well, so we can really accurately estimate the power consumption of the plant. As a byproduct of this predictive model, we can also look into these variables, these 14 variables, and analyze them and check which are the main drivers or the main responsible for the power consumption. It also gives us an opportunity to find out within these 14 most relevant variables which ones are sensitive to seasonality effects, like the external temperature. And as let's say a dashboard or a real-time analysis tool, you can train the model on historical data and display such a visualization where all the 14 variables, the main contributors of the power consumption, are actually displayed. So whether it's off, then okay, no problem, the consumption is low, it's normal. But if it turns red, then this means that historically the power consumption is higher than normal, maybe because of a wear out or a wrong setup of the operating cycle. We used open source tool for this, just a Python and a scikit-learn. And okay, as a conclusion, we had a successful model to predict the electricity consumption. We can provide to your R&D engineers ideas on how to optimize the energy consumption and to have a real-time dashboard to visualize the deviations. We spent about 40 man hours on that, and we don't regret it. We really had a lot of fun. It was a bit challenge because we had no idea about Spark before starting the challenge. So that was one learning opportunity for us. So thanks a lot for this challenge. Again, we had a lot of fun. Thank you.